Welcome viewers, in this video we'll see the details about SR flip-flop. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic SR flip-flop. We know that flip-flop is the storage element. The output is depends upon the input as well as previous state of the output. Previous state of output and the input will decide the output. Now we'll see this SR flip-flop. The SR flip-flop, also known as a SR latch, can be considered as the one of the most basic sequential logic circuit possible. So the SR flip-flop is the very basic type of sequential circuit. This simple flip-flop is basically a 1-bit memory bistable device. So it will be able to store the 1-bit data. What is bistable? Has two inputs. One is which is set, that SR refers set reset, right? One is set, that is mean memory. The meaning is the output is 1. Set means it will set the output as 1 and it is labeled as S. S means set, that is output is 1. And another which will reset the device. The meaning is 0, labeled as R, right? So we have they have the bistable device. Bistable means 2 stages. Set means it will make the output as 1. Reset means it will make the output as 0. So this S refers set, output 1. R refers reset, output is 0. Right? So we can set or reset the output of this circuit. Right? Set means 1, reset means 0. Then the SR description stand for set reset. The set input reset the flip-flop back to the original state with another output Q that will be either at the logical 1 or 0. Depends upon his set or reset condition. Right? Whatever may be the earlier data, 0 or 1, set mean it will make the output as 1, reset mean it will make the output as 0. Now we'll see the diagram of the SR flip-flop. So the two types available, positive edge and negative edge. Positive edge means whenever the clock pulse rises, the circuit will executed, the output will be executed. Negative pulse means whenever the clock pulse this goes down, goes to 0, it will execute it. So here now we'll see the positive edge. Whenever the clock pulse increases, whenever the clock pulse become the high level, then the circuit will execute. So we have 4 AND gates available, 4 NAND gates. 4 NAND gates are available. This is 1, 2, 3, 4. In 3 and 4, the gate non-gate 3, the S input is given, set input. In NAND gate 4, R input is given, reset. This positive edge detector clock pulse is given to both 3 and 4. We know that sequential circuit, for every clock pulse applied, the output is executed. The status changes from one state to another state when the application of the clock pulse. That's why it is called a sequential circuit. The combinational circuit, if you give the input, it will give the output. That is why small propagation delay. But the sequential circuit sequentially executes. Sequentially means every clock pulse, the state is changes. By sequence of order, the output is varied. Right. So in NAND gate 3, S input and clock pulse. NAND gate 4, R input and clock pulse. Right. So the output of this NAND gate 3 is connected to the NAND gate 1. 4 is connected to NAND gate 2. Right. This NAND gate 1 get this output bar, complement of the output Q bar is connected. In second NAND gate, the output is connected, Q is connected, right? So here we have S bar and Q bar, here R bar and Q. So this is the present state, Q bar, output complement of the output. Right, now we'll see, I will go to the truth table, what will happen if the input is applied, what are the possible outputs are available. We'll go to the truth table. Now we'll see some description, then we'll go to the table. The circuit is similar to SR latch except enable signal is replaced by the clock pulse. Latch means we have enabled signal, but here replaced by the clock pulse, followed by the positive edge detector circuit. The edge detector circuit is a differentiator. So it is used for clock pulse. The diagram shows input and output waveform for the positive edge triggered clock pulse. We will see that waveform later. The circuit outputs respond to the S and R inputs only at the positive edges of the clock pulse. At any other instant of time, the SR flip-flop will not respond to the changes in the input. So whenever the clock pulse goes to the positive edge, the output is produced. Now we'll go to the truth table and basic block diagram. So this is the logical diagram. S input, R input, clock pulse, output, complement of the output. CP means clock pulse. Right, this is the truth table. This is very important. The set already we discussed. Set means 1. Reset means 0. We are resetting the output as 0. So this is the clock pulse. This is the positive edge. Going upward means clock positive edge. Going down means negative edge. Right. So here it is going upward. So every clock pulse, the input output is executed. So we already know that this is the two inputs, S, R. This is the present state and next state, Qn bar. So this next state, Qn bar is Qn plus 1, not bar. Qn plus 1 is depends upon Qn and two inputs, SR. So Qn plus 1, next state depends upon present state and two inputs, right? So the two inputs, two variable, 4 combinations are available, 0, 0, 0, 1, 1, 0, 1, 1, right? So in this Qn is the one variable, 2 possibilities are available, 0 or 1, 0, 0, 0 or 0, 0, 1, 0, 1, 0 or 0, 1, 1, right? So S and R 2 variable, 4 combination, Q 1 variable, 2 combination, 0, 1, right? So 0, 0, if present state is 0, what will happen? 0, 0, if present state is 1, what will happen? So there are now 8 combination. S, R, Q and combinedly we have 8 combination. Right, now we'll see that. If both S and R is 0, what will happen? No change. Present state and next state, no change. What is the present state? Same thing will be available as the next state. There is no change in the state. 0 is 0, 1 means 1. Right? If both the inputs S and R is S, set and reset is 0, if the present state is 0 means next state also 0, present state is 1 means next state also 1. No change. This is called no change. Suppose 0, 1. 0 means set is 0, reset is 1. Right? We already know that what is reset. Reset means 0. So whatever may be the present state, next state will be reset, 0. 0 means 0, 1 means 0, right? It will reset the output, whatever may be the present state. The output is, the next state is 0, right? If the reset input is 1, reset means 0, so it will make the next state as 0. If already 0 means same state will be maintained, 1 means it will make it it will reset the output as 0. Then third combination 1, 0. What is 1? This is set. Set is 1, reset is 0. So what is meant by set? Set means 1. So it will reset, it will set the output as 1. 0 means it will set the output 1. If already 1 is available, that will be maintained, right? So the set input is 1, the output is set as 1. If the reset input is 1, the output is reset as 0, right? If both are 1, set and reset, it is an intermediate. It's not defined in the SR flip-flop. That is defined in JK flip-flop. One more topic available is available in the JK flip-flop, but in SR flip-flop, not defined. If the clock pulse is 0, whatever may be the input, 0, in present state 0 means next state also 0. Present state 1 means next state also 1. No change, right? If the clock pulse, whenever the clock pulse is applied, then only it will execute. Otherwise, there is no change in the output, right? So we have 0, 0, both are 0, 0 means no change. Set 1 means the output is set to 1. Reset is 1 means the output is reset to 0. Reset means 0, set means 1. If both are 1 means intermediate, not defined in SR flip-flop, that is defined in the JK flip-flop. The clock pulse is not available means no change in the input. Right. This is the truth table. From that we can go for the excitation table. That is a very important excitation table. Right, we will see what is excitation table. Is the output. From output we need to decide the input. So this present state, next state, S and R two inputs. For example, present state is 0, next state is also 0, mean what is the input we need to apply. Present state is 0, next state is 1, what is the input we need to apply. 1 to 0, what is the input we need to apply. 1 to 1, what is the input need to apply, right? From output we are checking the input, right? First we will see 0 0. Input is also, present state is also 0, next state is also 0, mean what is the input we need to apply. Now we'll check this truth table. Wherever we have 0 0, here 0 0 is there, here also 0 0 is there. Present state and next state 0, no other, only these two combination, this first and third. What is the input here? 0 0, here 0 1, that is S is 0, but R may be 0 or 1, so that 0x, right? See, this present state is 0, next state also 0. That can be decided from this truth table. We need to check for which combination we have present state is 0 and next state also 0. There are two combinations, this first and third. First and third there is no change, 0 0 is maintained. Present state 0, next state 0. What is the input here for this first combination? 0 0. S is 0, R is 0. Third combination, third output, S is 0, R is 1. So in both the cases S are 0. Only R may be 0 or 1. Right? So S equal to 0, R is any case, will get 0 0 as the output. So S is 0, but R may be any value, X, that is represented as X. Then we'll see 0 1. Present state is 0, next state is 1, mean what is the input. See where it is, we have 0 1, this is 0 0. Here we have 0 1 is there, only 1, all no other thing, only 0 1. Present state is 0, next state become 1. What is the corresponding input? 1 0. S is 1, R is 0, 1 0. Only one combination. Then 1 0. Present state is 1, next state become 0. Where it is available? It is available here. 1 0. Right? Though no other thing. No other combination. What is the corresponding input? 0 1. Set is 0, reset is 1. Set is 0, reset is 1. Then 1 1. Present state and next state is 1 1. We have to check. Here is available. 1 1. Here one more 1 1 is there. Two combinations. Second 2 3 4 5 6. Then second output and second combination and sixth combination we have 1 1. What is the corresponding input? 0 0. S is 0, R is 0. Here what is the corresponding? S is 1, R is 0. Right? Here 0 0, 1 0. That is R is 0, here also 0, here also 0. But S is here 0, here 1. So S may be any value, X, and R is 0. So this is the excitation table. From the output we are checking what is the input, right? So 0 0 mean if we give S equal to 0, R is any value, mean present state and next state will be 0. 0 to 1, if you want to change the present state 0, next state to be 1, mean you should give S input is 1, R input is 0. If you want to change the present state 1 to 0, the input what we need to give, S is 0, R is 1. We want to maintain present state also 1, next state also 1, mean whatever may be the S input, R should be 0. Then we'll get this output, right? So the excitation table we got from the truth table. From the output we are deciding the input, that is called the excitation table. Right, now we'll see the truth table in a shorter form. 0 0 means this is next state, this is present state. Next state and present state both are equal. 1 0 means set. Set means it is set the output as 1. 0 1 reset. Reset means 0. Both are 1 means no change. There is not defined in JK flip flop, SR flip flop. It will be decided in JK flip flop, right? Both are 0, same. Present state and next state are equal. 1 0 means set, 0 1 means reset, right? Now we'll see some more detail and clock circuit. So the case 1, if S and R both are equal to 0, the clock pulse is applied, the output do not change, there is no change. Next state is equal to present state. Case 2, if S equal to 0, R equal to 1, then output pulse is applied, the next state is 0. R means reset, so the output is reset to 0. If S equal to 1 and R equal to 0, the clock pulse is applied, the state of the flip flop is undefined. It's not undefined. The state of the flip flop is 1. Q n plus 1 is 1, right? If S equal to 1 means set. If both are 1, that is undefined, right? Now we'll see this clock pulse. So this is a positive edge triggering clock pulse. Whenever the clock pulse increases, rising, this is called a negative edge, down, going down. This is going up. So whenever clock pulse going to positive, this is called positive edge, increasing. This is called negative edge, going down. Here from 0 to 1, positive edge. 1 to 0 is the negative edge. So whenever the clock pulse increases, there is a change in the state of the flip flop, right? So S and R both are 0 means no change. S equal to 1 means set. Set means output is 1. Next state is 1. Then 0 1 reset is 1 means the output will be resetted to 0. If both are 1 means undefined. So in this video we discussed the SR flip flop, basic block diagram, truth table, excitation table and the clock pulse. Now we'll verify one of the input. Now we'll check how the states are changes. Now consider this fourth combination. S is 0, R is 1. What happened? The present state 1 is changed to next state of 0. 1 to 0, right? So S is 0, R is 1. Present state is 0, that will change to present state is 1, that is changed to 0. Now we'll verify this output with the logic diagram. See, S is 0, R is 1. And another input is positive clock pulse. Whenever the clock pulse applied, then only it will work, right? So S is 0, R is 1, clock pulse is 1, 1. Then present state what we discussed, 1. That should changes to 0, right? 1 to 0. We'll verify whether this 1 is changed to 0. Q is 1 means Q bar will be 0, right? Now we'll check this. 0 and 1. What is the NAND gate output? 0 and 1 means 0. Because of NAND gate, it become 1. 0 into 1 is 0 in AND gate. In NAND gate, it is complemented. This is 1. 1 into 1 is 1. But due to NAND gate, it become 0, right? So this output of this third NAND gate is 1. Fourth NAND gate is 0. Now we'll see here. This 1 is applied here. So Q is applied. Q is 1. Q bar is applied here. That is Q bar is, this Q bar is 0. Q bar is 1, is given as 1. So here the S bar is 1, R bar is 0. This 1 is applied here. From down to up we need to go, right? Presently it is 0. Now changed to 1. That 1 only applied. We need to follow the logic either from bottom flip flop to top or top to bottom. Now we'll follow from bottom to top, right? So 1, here also 1. First we'll see this, then we'll go to the flip flop 2, NAND gate 1. So see here the output is 0. This Q is applied here. So 0 into 1 is 0. Due to NAND gate it become 1. Now the Q bar is 1. This 1 will be applied here. This 1 into 1 is 1. But due to NAND gate it become 0. Now it is changed to 0. Right? We have to follow from bottom to top. Because both are interconnected, we don't know what will happen. Both will be executed simultaneously. In order to study, in order to go with the theoretical, we follow from bottom NAND gate to top NAND gate. Some other combination we have to follow top AND gate to bottom NAND gate, right? There is some procedure is available. There are 8 combination, 4 combination we have to follow from bottom to top. 4 combination we have to follow from top to bottom, right? So I will explain again. Here S is 0, clock pulse is 1, R is 1, clock pulse is 1. We have Q is 1, that should be changed to 0. We need to check whether the Q is changed to 0. Q1 means Q bar is 0. So 0 into 1 is 1, 0 into 1 is 0, but due to NAND gate we got 1. 1 into 1 is 1, due to NAND gate it becomes 0. Now this 1 is applied. 1 into 0, 0, but due to NAND gate we got 1. This 1 is applied here. 1 into 1 is 1, due to NAND gate it becomes 0. See this, the output is changed from 1 to 0. Similarly, we can verify the other output or other combinations also. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.